Hello friends, welcome to my class of physics. In the last class we have discussed the basic of wave theory of light. There we have seen how a wave can be constructed and I have also introduced the concept of wavefront. Okay, now in today's class we will see those concepts of wavefront in more detail, and also we will discuss the Huygens principle of wave. Okay, so let's see. Now if we see the figures in the left figure, where we can see the source is a point source, we draw some concentric circles, right? So these concentric circles are called wavefront. Now on these circles you can see there are some pink dots, right? So these pink dots are called wavelets. Now let's understand in detail. So when we throw a stone in a pond, we see that at a particular distance, all water molecules are vibrating in the upside direction, and at a particular direction, particular position, all the molecules are vibrating in the downward direction, right? Now here also the same thing is happening. So the from the point source, when the disturbance reach to a particular distance, all the molecules in the medium vibrate in the same manner. The state of vibration, state of oscillation of those molecules or particles are same. So those particles are actually we are indicating here as a pink dots. So when those particles vibrate, the disturbance coming out from those particles, so those particles are the source of the secondary disturbances. So these particles, these points are basically treated as wavelets from where the secondary disturbance is coming out, and again we get another circle of greater radius, right? So in 3 dimension, these all will be in shape of a sphere. So this wavefront will be a spherical wavefront. Now for a linear source, the pattern will be you can see the wavefront will be cylindrical, and for a infinite source the wavefront will be planar wavefront. And this red line is basically showing the direction of the propagation of the disturbance, that is the light ray basically. So that will be perpendicular to the wave front, and here this planar wave front when the source is infinite. Okay, so always remember that the direction of the propagation of the light is always perpendicular to the wave front. Okay, now let's discuss the Huygens construction or Huygens principle of wave, which already we have discussed in the last slide. Now in the left side you can see the source is point source and we are getting spherical wavefront, and in right side we are getting planar wavefront as the source is at infinite distance. Now here the solid blue lines is basically called the primary wavefront. On the primary wavefront you can see we draw some red dot points. So these red dot points is called the wavelets, secondary wavelets. Actually from these red dot points disturbance will be coming out. So each point on this wavefront acts as a fresh source of disturbance of light. So these small circles we can call as secondary wavefront. Now if we connect the top of these small circles, we get another wavefront, right? So the new wavefront at any later time is obtained by taking forward envelope on all the secondary wavelets at that time. Okay, now the backward direction there will be no propagation of disturbance, right? So mathematically how we can justify this? So amplitude of secondary wavelet, you can see, we can consider as proportional to half 1 plus cos theta. So in the backward direction, this theta will be 180 degree, and in that case the amplitude will be 0. So that's why we always get a forward direction, not backward direction. In backward direction there will be no propagation of wave. Okay, so this is the Huygens principle of wave. Thank you.